So chapter 8 is about the graphs of the sine cosine function, which we call periodic functions. Tangent, cotangent, secant, cosecant, you're going to find finally why they're named what they are. Sine and cosine graphs are going to look the same or similar. Tangent and cotangent graphs are going to look similar. Secant and cosecant graphs are going to look similar. So they were actually named based upon their graphs. So cofunctions like a sine and a cosine are cofunctions. You actually can convert them back and forth between the two as far as their graphs go. So we're going to explore the graphs of sine in this first video. Then we'll do cosine. We'll practice those before we move on to the others, because we really kind of have to grasp how each one of our trig function looks like and how we deal with it. So this is where your unit circle will definitely come into play. So we're going to focus on the sine function. We're going to break that apart. We're going to look at the sine function. We're going to practice graphing that before we move on to the cosine. So the first thing I want to look at with you is a little video. So everybody, just take a look at this video. So we're going to think about on the unit circle, the sine value is the y value on our unit circle. So in green here, you're going to see the unit circle, and you're going to see how as it rotates around the circle that it uses those y values to build a graph. So everybody, let's look. So as our y started at 0, it gets up to 90 degrees in a second. I put it on slow-mo so you could see it. So when it hits 90 degrees, our sine curve is at a height of 1. Now it has to come back down, right? It's getting smaller and smaller. It has a height of, about 1/2 at this point. It's getting to a height. Remember, the sine is the height. It's getting to a height of 0. Now it's going to go negative, right? So as we go in that third quadrant, our sine value is going negative, and now it's about a negative 1/2, and it's come down to -1. And then in the fourth quadrant, it's going to come back up again. Now, as we loop across the unit circle, that will happen again and again and again. So we will see that that's why it is considered a periodic function. And let's say that we go backwards, that's going to give us this other end of the graph, okay? So that is how we can see how it's related to the unit circle. So let's go ahead and look at how we use these graphs. So the first thing you want to think about is you want to think about what should you count your x's by. So you'll notice here that we've counted our x's by a radian measure. So I've counted this is 0, pi over 2, pi, 3 pi over 2, and 2 pi. So let's put those down for our x's. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Sorry, my stylus died a little bit. So you get to see my lovely handwriting like that. Okay, now let's think about on the unit circle. So let's look at I've included a little unit circle here. The sine values are the y's. So let's focus on the y's from 0. It's at 0, and then at pi over 2, it gets to 1. And then at pi, it is at -1. At 3 pi over 2, I'm sorry, it's back to 0 again. At 3 pi over 2, it's back at -1. And then that cycle is going to repeat itself. So let's write those y values in. So at 0, we're at 0. At pi over 2, think about on the unit circle, what is the sine of pi over 2? It's 1. The sine of pi is back at 0 again. 3 pi over 2 is -1, and 2 pi is back at 0. So that is a pattern that you have to have memorized. The fact that 0, 0 is our starting spot. Then at pi over 2, we go up at 1. At pi, we're at 0. At 3 pi over 2, we're at -1. And at 2 pi, we're at 0. So make sure that you start to write that pattern down a little bit. Every time you do a sine problem, write that pattern down. And now let's actually graph it on our graph paper. So I'm going to make this 1 and this -1, okay? So I'm going to count so that just so we can get a nice graph. So at 0, we're at 0. At pi over 2, we're at 1. At pi, we're back at 0. So that is our first bump in our wave. Now, a periodic function means that this wave is going to repeat itself. Think it's a wave heading toward the shore. At 3 pi over 2, we're at -1. And at 2 pi, we're back at 0. One cycle of our wave going up, going down, and coming back up again before it repeats itself, because this graph is going to repeat itself in all directions. This periodic function, one cycle of the wave, is considered a period of our graph. So let's draw our wave so that it continues in the negative region. Think about the fact that our wave has to go up, then down, then up, then down. So this tells us that is at -1 and then back at 0. So we can do a down bump. Sorry, my stylus here is not cooperating real good. I'm sorry. And then at -3 pi over 2, we are going to go up and back down again. So our wave is going to repeat. You should always fill up the graph paper. And remember that this wave keeps doing that for all eternity. Now, some things to think about for our sine wave. The maximum is always 1. The minimum is always -1. It is a continuous function without any breaks in the graph. It is always stuck between +1 and -1. So that is something that we really have to think about. That's why when I was talking about when we were doing the law of sine and cosines, the fact that your sine and cosine should always get a 0 point something, or maybe could be +1 and -1. A sine value is always between +1 and -1. Okay. Some facts to know about the sine graph. The sine graph is an odd graph. I could put a push pin right here in the middle. I could spin it at that push pin 180 degrees, and it would look exactly like it started. So the fact you want to learn is if you put the sine of -x, say, into Desmos, or if you put the negative sine of x into Desmos, they're going to be exactly the same. So for a sine function, you can take this negative here and move it out in the front. So that is a fact that you're going to have memorized. So the fact that the sine of -x is equal to negative sine of x is all about the fact that it is an odd function, and the symmetry makes it so the negative on the inside can be removed and brought out to the outside. Some general things that you want to know, okay? Some general things we want to know about the sine function. The A tells you the heights of the bumps, tells you the heights of the wave from the center, okay? If the A is negative, it will flip it over the x-axis, and I think that's what it was trying to say there. It kind of got cut off a little bit. But if it flips it, if it is negative. Next, this section right here, if you set it equal to 2 pi, that will tell you how long until our sine function repeats itself, a period of the wave. So you need to know that word period is normally 2 pi, but it can change if we stick something on the x. If we stick on the x a number larger than 1, then it is going to actually squish the graph. So think of that sine wave as like a slinky. So If the slinky is kind of pulled out, that's its normal state. If the b is a number more than 1, it's going to squish the slinky. If that b is a fraction, like 1/2, a proper fraction, it is going to pull the slinky outward. Next, if you put parentheses around there, if you think about what's inside, if you set that equal to 0, that is going to tell you how the function moves left and right. We know that about functions. The thing on the inside is going to possibly move it left or right. We call that something different, though, in trigonometry. That left or right movement we call a phase shift. So that is some language that you're going to have to know. And then finally, this number here, if we add it on the outside, what do we know it does? It moves it up or down. That is called a vertical shift, or that also gives us something called the midline. Okay, so that is some new language. It actually does all the stuff we know from before, except we got some new language going on. This number changes the height of the graph, stretches it. That is going to be referred to and tell us about the amplitude. This term here can pull the slinky apart or push it closer together, pull the spring apart or push it back together, and it refers to the period. We normally set it equal to 2 pi because that's the original, but if there is something attached to the x, it's going to change that. Take this entire parenthesis, set it equal to 0. That's going to tell you where we move the function left or right, called the phase shift. That's called the midline or vertical shift, and that's all related to the number on the outside. So those are all facts you're going to have to know. And I will keep walking you through the process every single time so that you know that language and you know some of those new things. And then right below there, I have an example that I would like to do. And I would like to find the amplitude, the period, the phase shift, and the vertical shift in midline for the graph that you see there. So we're going to practice getting that first before we actually look at the graph. Okay. So I'll give you a second to get all those, whatever you need to write down about that. Everybody have everything you need highlighted or whatever? Okay. So let's look at our first example. So the first thing I want to find is the amplitude. Sorry about that. The amplitude is going to be related to this number right there. The amplitude is that A value. So the amplitude is just going to be our A value. And it's actually going to be the absolute value of it because it's just the height of our wave. And when we say, what is the height? We don't put any negatives with it. The negative is going to flip it. So this graph will have a flip across its middle line. But the amplitude is actually 2. Next, we're going to talk about the period of the graph. For the period of the graph, we're just going to take 2x, whatever's attached to our x, and we're going to set that equal to 2 pi. You always set it equal to 2 pi for every one of our functions except for a tangent and a cotangent. So we're going to set that equal to 2 pi. And then you just solve for x, so we got to divide both sides by 2. So x is pi, and that is our period. Now what does that tell us? Well, that tells us that this graph does a wave in an x length of pi. So it'll go up then down at a pi's length, and then up then down at a pi's length. Next, we're going to set this entire parenthesis equal to 0. So that is going to tell us our phase shift. I'm just going to write the word phase. So we're just going to set 2x minus pi equal to 0. That parenthesis, set it equal to 0, and then we're going to solve for x. So let's do that. So we're going to add pi to both sides, and then we're going to divide by 2. So our phase shift is positive. That tells me we're going to go to the right. If our phase shift is negative, it's going to go to the left. So this function has a period of pi, an amplitude of 2. It's been flipped upside down, and it has been shifted to the right, a pi over 2. And then the last thing is probably the easiest. It's this number right here. That is our vertical shift, or midline, which we can just call the middle of the graph, is at y equals 3. So finding these things about the graph are pretty easy if you just stick with my little plan here. This number gives us the amplitude. Just take its absolute value. This number gives it the period. Just set it equal to 2 pi. This whole quantity gives us the phase shift. Just set it equal to 0. And this number gives us the vertical midline, which you just set that y equals that number. Okay. So those are some new terminology you're going to need for sines. Some characteristics that you need to know is that the sine and cosine function normally have a period of 2 pi. I'm talking about the parent functions here, y equals sine of x and y equals the cosine of x. The domain is all real numbers. I can plug in anything I want. The range is -1 to +1. The symmetry for a sine is going to be odd. For a cosine is going to be even. The amplitude normally is 1. So those are just some facts about our originals before we mess them up. Those are just some facts that you need to know about the originals. Okay, so the period of our original parent is 2 pi. Our domain is all real numbers. Our range is from -1 to +1. You'll notice they have brackets on it because there is a topmost value of 1 and a bottom value of -1. The symmetry, the sine is odd and the cosine is even. I would add a little note here. That means that the sine, I'm so sorry, the sine of -x is the negative sine of x. That's what it means to be odd. And the cosine is even, so that means the cosine of -x is the same as the cosine of x. So that's just some facts, and we'll explore that even and odd a little bit more as we go through the graphing process. So we'll explore that more as we go. So make sure to write those down, and then we'll go ahead and look at our first example of actually graphing. I believe that's what's next. Yeah. It's all about the graph. So if we look at the symmetry, the sine function can be spun around the origin, and it doesn't change the graph. So that's what mathematically, if you put a negative on the inside, it flips it across the this axis, which is the same as flipping the original upside down. Okay, so that's why the sine does that. We haven't looked at what a cosine graph looks like yet, but we're going to get to that. The cosine graph is can be split down the middle, right down here. Can't you fold it across there? So if I flip it across that line, does it do anything at all? And that's why. And so it's just something we'll explore as we go through the process. But it's all about just the characteristics of the original graph. It's all about what the graph looks like and the symmetry of it. This flips it across, that -x flips it across the y-axis. So if you flip it across the y-axis, what does it do to the graph? Well, this one, it ends up flipping upside down. This one, it doesn't do diddly squat to it. And that's why it does that. Everybody got that stuff written down? Okay, let's look at our first graphs then. Okay. So let's always get in the habit of writing the original y equals sine of x, the values of the original in this spot. So it's going to be 0 is at 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is -1. And the sine of 2 pi is 0. So that's our original. Now we're going to mess it up, but that's what our original function is, okay? So that is something you have to memorize. And it's all from the unit circle. I didn't just, make that up. Okay, let's start with the amplitude. The amplitude of the graph is any coefficient that's stuck on the front there. There's nothing stuck on the front. So it's just the absolute value of 1 or 1. So that's nice. The period is related to this number right here. You just set it equal to 2 pi and solve for x. Well, it's naturally solved for x. So if we don't mess up the x, the period is always going to be 2 pi. The phase shift, where did it move, left or right? You're going to set that entire parenthesis equal to 0. And you're going to solve for x. So we have gone a pi to the right. That's actually our starting value on the new function. Okay. Next, what is our vertical shift? Have we moved up or down any? That's this number right here, y equals 1. Sorry. Y equals 1. So we've gone up 1. Okay. Now, if we've set the inside equal to 0, we found it moved to the right. If you set the inside equal to 2 pi, we will find out where it ends. So how would you solve that? Well, we would add a pi to both sides. 2 pi plus 1 pi is a total of 3 pi's. So its ending spot is 3 pi's. Now, here's something you got to remember. These things are always equally spaced. So what is smack dab in the middle of a pi and a 3 pi? What's right in the middle of a pi and a 3 pi? A 2 pi. So that means a 2 pi is in the third spot. Now we have to think about fractions. What's exactly between 1 and 2? What's 1.5, right? Now how do we write that as a fraction? 1.5 is the same as 3 halves. We know that in our unit circle, 3 pi over 2 goes right here. What's exactly between 2 pi's and 3 pi's? 2.5 pi's. How many halves is that? That's 5 halves, right? 5 pi over 2. Everything is always equally spaced. Okay. Now we got to find our new y's, and this is the way I think about it. Okay, I'm going to write it up here for a minute. This we have forced to be the old y values, okay? So all we got to do, the only thing on the outside of that function is that plus 1. So all we're going to do is take the old sine values from, that's why you memorize this, the old y values, and we're just going to add 1. So all we got to do is 0 plus 1. 1 plus 1. 2 plus 1. No, 0 plus 1 again. Sorry. -1 plus 1. And 0 plus 1. So we have our y's. Yes?
Wouldn't the 3 pi over 2 be 0?
No, we're adding 1 to all the original y's. We're adding 1 to all those original ones.
We don't have a pi over 2.
3 pi over 2, when we stick it into here, we would subtract a pi, which would force it to be a pi over 2. So if we plug these into the original, they end up being the old y values again, because this would be the sine, pi minus pi is 0. We are forcing this one to be our starting spot and this one to be our ending spot. And so we end up being the old original spot plus 1. So it's the old original y's plus 1. And you can plug them into C if you want. You can actually plug them in. Okay, so now we're ready to graph them. Our graph paper, we have to count on the x-axis by pi over 2's. So just so it fits, let's make this pi over 2. I'm so sorry, goodness. Let's make this one pi over 2. Let's make this pi. Let's make this 3 pi over 2. Let's make this 2 pi. I'm going to extend this a little bit. And I'm going to make this 5 pi over 2. Wait, do we go up to 3 pi? I'm sorry, we're going to change it. Sorry, let's make this pi. Let's make this 2 pi. Just so we can fit 3 pi, 4 pi. So this would be negative pi, negative 2 pi. You just got to kind of gauge how to make your graph paper work for what you're doing. Now, our highest y value I see is 2. Our lowest y value I see is 0. So let's just, count normal. Let's make that 1 and 2. Now, when you're graphing these, the first thing you want to put on your graph paper, the very first thing you want to put on your graph paper is that middle line. We know that middle line is y equals 1. So at 1, please make a dashed line. So you always do that first. That is the height of the water. That is how your wave is going to go up from there, down into the water, and then up from there, and then down into the water. That's the middle of our graph. It should be the middle of our graph, or you're not going to graph these right. Okay, so our first value at pi, we are at a height of 1. So at pi, we are on that middle line. At 3/2, or between pi and 2 pi, we're at 2. And then at 2 pi, we're back at 1 again. So the sine will always give you a bump in the first 3 values. And as long as there's not a negative in front, it will always give you a bump going upward. Now let's continue. At 5/2, or 2.5 pi's, we're at 0. And then at 3 pi's, we're at 1. So we have finished one period of the graph, and it should have taken us 2 pi's to do that, and it did. Now, if this would be a quiz and you would give me that much of your graph, I would take some points off. A sine or cosine function spreads forever left and right. So now that you know the pattern, everything is equally spaced and going up then down, up then down, up then down. Draw the rest of your graph. Fill in your graph paper. So this one has to be an up and a down. That has to be an up bump. This would be part of our down bump. And we could finish that bump if we wanted to. Down, up, down bump. Up, down, up bump. It has to be equally spaced. It has to be a perfect wave. And I'm sorry, I can't graph very good. But there is our periodic sine function. So that's your first graph. And I'll zoom out here in a second so you can, if you missed any of the other stuff. If you don't know your unit circles, or you don't know the fact that the sine of 0 is 0, it's really hard to get these graphs. So please make sure that you can loop yourself around the unit circle and go 0, 0, pi over 2 is 1, pi is 0, 3 pi over 2 is negative 1, and 2 pi is back to 0 again. So there is our first graph of our sine functions. Any questions about what you see there? Yeah.
Where did you get the x minus pi equals 2 pi and x equals 3 pi?
Okay, so to find your starting x value and ending x value, you always set this entire parenthesis equal to 0. That's going to be your starting x value. And then set it equal to 2 pi. That will be our ending x value. That's how we found pi and 3 pi. A normal sine function starts at 0 and ends at 2 pi. So we are seeing how the new function, where does it start and where does it end? And then you first, so that's where it starts, that's where it's end. Next I get the smack dab in the middle one, and then I cut these ones in half to get these ones. Because everything is equally spaced. So if I know the start and I know the end, I know that it should break down into 3 more chunks. So I should break it down into equal spots from there. So halfway between pi and 3 pi is 2 pi. Halfway between these two is 1.5 pi's. Halfway between these two is 2.5 pi's. Okay. Okay. One more. Now I made this one a little bit harder than the last one just so we can see one more hard function. Okay, so the first thing I want you to do always is write down your original values as reference. So the original sine function goes 0, 0. Even if you remember that the sine starts at 0, it's helpful, okay? And then pi over 2, it's at 1. The sine of pi over 2 is 1. Then pi is 0. 3 pi over 2, the sine is at negative 1. And at 2 pi, the sine is at 0. You have to know that pattern by heart, okay? You have to know that pattern by heart. So that's our original. We're going to use that as reference as we go through the process. So the amplitude is the absolute value of that number right there, or 2. Please note that there will be a flip. So instead of this graph, the normal sine function makes a bump up, then a bump down. This one is going to make a bump down, then a bump up, and you should expect that. This is going to tell us what the period is. We're going to take 2x and set it equal to 2 pi. And you're going to solve for x. So we just divide the 2 off from both sides. So this graph is going to be smushed a little bit. It is not going to do its wave in a 2 pi. You always set it equal to 2 pi and then solve for x. Yes? Yeah. So this negative in front, just like what we learned about if there was a negative in front of a parabola, or negative in front of it always does those same things. If we add here, it should move it left. If we subtract there, it should move it right. If we add out here, it should go up. If we subtract out there, it should go down. Now we just have some terminology that's a little different. Okay. Phase shift. Remember, you're going to set this entire parenthesis equal to 0. That is going to be our starting spot on our graph. So where does 2x plus pi equal 0? Well, you're just going to subtract a pi and divide by 2. So our starting spot is negative pi over 2. So that means that our graph has moved to the left. Now let's see what our ending spot is. So I'm going to set 2x plus pi equal to the normal ending spot of 2 pi and see what happens. Well, let's subtract a pi from both sides. We get 2x equals pi. Divide by 2. That's pi over 2. Okay. Now let's fill in our x's before we go any further. What's smack dab in the middle of negative pi over 2 and positive pi over 2? What's smack dab in the middle of negative pi over 2 and positive pi over 2?
0.
0. Let's put that. That's our middle value. Now let's do this one first. What's between 0 and 1/2? If the pi wasn't there and we were just doing fractions, what's exactly between 0 and 1/2? What's exactly between 0 and 1/2? Close? 1/4. So this is actually, just divide that fraction denominator by 2. You've cut it in half. That's pi over 4. So what's halfway between 0 and negative pi over 2? Negative 1/4. So negative pi over 4. So just think fractions. Kind of ignore the pi and just pop it back on. Okay. So now we've got our x's. Now let's take a look at the vertical shift, or the midline. The vertical shift is just that number right there, y equals -1. So this has gone down 1, so the middle of our graph is at -1. So how do you find your y values? Let's talk about that. So this is going to be y, our new y is going to be -2 times our old one minus 1. This we have forced to give us those old values, that 0, 1, 0, -1, 0 pattern. So we're just going to take the outside stuff and apply it. So we're going to do -2 times the old chart minus 1. Okay. So -2 times 0 is 0 minus 1 is -1. -2 times 1 is -2 minus 1 is -3. -2 times 0 is the next one, is 0 minus 1 is -1. Now I'm using this one. -2 times -1 is 2, minus 1 is 1. And then finally, I'm using this one. -2 times 0 minus 1 is 0 minus 1. Things to check for a sine value, kind of to know if you're right. These three should always land on that middle line. Wherever your middle line ends up being, those three will always match on a sine. So if they don't match, you did something wrong. Okay, so let's get our graph paper to match. So I need a middle line at -1. So let's just make that, we'll count by ones. Our graph paper, we need to count by fourths. So let's do a little trick. Let's do 1, 2, 3, 4. Let's make that a pi. So then it'll be in fourths. So let's make that pi. 1, 2, 3, 4. That's 2 pi. 1, 2, 3, 4 to the left. That's -pi. 1, 2, 3, 4. That's -2 pi. So I'm just counting by fourths. I'm sorry. You're welcome to change it the way you want, that you think it's going to fit. I counted by pi over 4s because of the fact that our largest denominator was fourths. So as long as you mark it, you can do whatever you need to do to fit yours. Yeah, it's very ugly, but that's a -pi. Okay, so you can do that. So now let's go ahead and graph it. Okay, so at -pi over 2, which is -1/2, which is right here, we are at -1. So our first one is here. At -1/4, we're now at -3. And then at 0, we're back at -1. Now remember, I said it's flipped upside down. Normally our first bump goes up for a sine. That's why our first bump goes down this time. And then we're going to go up and then down again. Everything is equally spaced. So that is one period of the graph. It started at negative 1/2 of a pi and ended at positive 1/2 of a pi. A sine hits the midline 3 times, hits the middle, down, hits the middle, up, hits the middle. There should be 3 values. Your first, your middle, and last should always be on the middle line for a sine. And now let's extend it. Equally spaced, up. Equally spaced, back down. Equally spaced, up. Now, you might decide to count slightly differently than I have, and as long as you mark your graph paper accordingly so that I know how you decided to count, but we should always fill up our graph paper as much as we can. Okay, so we kind of know it's doing something like that. So these are not going to be easy. These are going to take a lot of time to see how to do it. You're going to have to do it by hand. You can use a red calculator as you're doing any of these if that helps you with the fractional portions of things. But on any quiz or anything like this, there's no graphing calculators, no Desmos, nothing like that. Okay, and then the homework follows below. There are just 4 sine functions that you have to graph, and then we can do together whatever we need to. But I would like you to take a look at what those functions are and how you do that. So there you go. There is how we graph a sine function based upon our unit circle values.